All right, we're on yet another recording. So what is your question? Which recursion problem are we looking at?
We're looking at in the first exercise, the last method, the the Boolean method, count if 10 times.
Okay,
Yeah.
excellent, excellent. All right, so let me first of all set the stage by. Let me see if this is useful. So we're talking basic manipulations, the proficient level of counting 10 times another value. All
Yep.
right. So I shut my camera down, but maybe it'd be useful to do this on paper now that I have it up. Yeah. All right. So I'm gonna create a new array. I've got a whole stack of junk paper right here. So we have a list. Uh, again, zero is on the list. Zero is a special case. I'm not going to do it here just to make our life a little bit simpler, but I just want to remember zero is a special case. So we have a list of 1, 3, 5, 7, and 10. We'll just put 5 items on the list. It's a nice number to deal with. All right. So, how do we manage our recursion if we aren't looking for things within it? So, if I just say find how many times the number uh, 10 shows up on the list. So, you can talk this out, or you can just um, with somebody can talk it out in a second. I want everybody to think about this for a second first. All right, so we find the base case, right? So the base case is either one item at the start or the last of the list, doesn't matter, but it's one item. And we say, is this a number 10? And if this is a number 10, then return 1. If it's not a number 10, I return a 0. And then I consider a list of 2, and I take the results of 1 and add them to be, in this case, I've chosen the last item. Is that a 10? And so essentially this grows binary. So I take a 1 or a 0 plus a 1 or a 0, and then I have a list of 3. So I take the answer for the list of 2 and add to it, is the last item a 10 or not, and so on, right? So the same premise works, but the first thing to understand is I do not have, so the call that I said to you was, it's a Boolean result. Find 10, I think is what I called it. I'm kind of I looked it up here. 10, I'm sorry, 10 times what I called it. Let me just make it accurate. Tentimes. And I passed into an array of values. It's an int array. And the size. So the first thing to understand in recursion is this is the interface into the recursive method. This does not have to be the recursive method. So if I call you and say, go find me every entry in the entire world of a person who's named Tony, you don't have to do it all in that method, in that function, in that procedure, right? I can go off to a bunch of databases and call functions and say, hey, you know, The United States Social Security Registry. Give me everybody whose name is Tony, and the Chinese social whatever their equivalent is inside there. Give me everybody who's named Tony, and in Canada, give me everybody who's Tony, and then in Australia, give me who's everybody's Tony, and in South Africa, everybody's Tony. I can make a bunch of sub calls inside of that, right? I can create helper functions. So the first thing to remember is this is just one function. This function doesn't have to call itself. I can create another function for this, right?
Yeah.
So given that premise, it doesn't necessarily mean like, oh, now I understand it all. But think about it for just a second. I don't. You have to think about it long. But let's take 60 seconds and think about how I would do this differently. So if I have a list of one, it's useless. The base case doesn't mean anything anymore. It's a different base case, right? Because I want to know if two values are 10 times each other. So, but it's not two values next to each other that are 10 times to each other. So that's a little bit of a difference as well. But I can say if I'm down to two values, then I only need to compare those two values. But given a list of values, well, what do I want to do? I want to compare this one of the values in the list. Could be, again, the nice pattern is the start or the last one, because they're always going to be at an end. I can always either compare 0 or length minus 1. You never know what the middle value is going to be. You never know what the third value is going to be. There might not be a third value. So working with the ends is good. So if I know how to iterate a list by looking at the last or first value, well, what do I do with that first value?
Oh, you gotta change it for you gotta remove it after you look at it,
Well, that's true
right?
for iterating the list, but let's say I have a list of X number of values. What do I, and I'm saying I want to check, is this first value 10 times any of the rest of these values? Or the other way around. You can search both at the same time. Is this 10 times any other values, or any of the other values 10 times this? That's a great little saving right there.
You make them equal. You ask if they're equal.
Right. But how do so basically I start with one value, I have to compare that against all the rest of them. And then I do a smaller list. I start with this value and compare that with all the rest of them. I start with this value and compare that with all the rest of them. I start with this value and compare it with all the rest of them. So you see, that's the trick. I now need two different approaches. Now, again, just think about it for a second. Given that, what values could I pass in that would reflect this?
I mean,
So just take a second and think about it. I mean, I appreciate you jumping out there, but there's a couple other people thinking about it. All right, so we're going to have a second method. We actually, in C, we can call it 10 times as well. That can be a little bit confusing, but the rules of overloading, as long as the parameter list is different, we can call it 10 times. So we clearly need the original list. And we need the size of the list. I mean, we need a list, not necessarily the original list. We need a list. We need the size of that list still. This is, again, that drives me crazy in C. Why do I have to pass that? This inherently has a size. Why do I have to pass it along? Oops, I don't want this here. But it's a function of being super lean savings language. If I don't need to know the size, then I never have to worry about it. I don't know what things I don't need to know size for. Um, so here's another thing I can change here, where the size, well, I'm going to change size to a variable called original size. So I don't have to slice my array up. So I have an array, its original size is 5. But I can treat this array as being something smaller by just saying, well, just ignore the last item, ignore the last item, ignore the last item. So I have the original size, and then I have the size I'm working with. Okay, so I can add that one parameter. But as I said, it's not just a matter of the size, so I can shrink the size. I also need to know which one am I looking with. If I do the size, then I can compare one to all the rest of them. But I can also say, well, this is the one I'm working with, and this is the one. This is the size. So I compare this one to all the rest of them. Well, I don't know how to do that, but I can compare this one to all the rest of them. I compare this one to all the rest of them. Let's compare this one to all the rest of them, right? And at that point, then I know I get to a base. Well, at some point, I know I get to a base case. But I don't want to just do the first one. I also then want to do the second one, and then I want to do the third one. So it's not just the size, but it's also the position right here. So let's take a look at. I'm not going to do it in code here, but I want to show you what this looks like. So when I say 10 times and I pass in this array, the first call to that looks like 1, 3, 5, 7, and 10. That's going to be the same all the way through. It's going to be all the way through. It's going to be the same. But the first call of this, the original size is 5, and that's going to be the same all the way through. 5, 5, 5. That never changes. So the size we're working with to start with, the very first call is also 5. And then the position we want to start with can be anywhere on this list. So we'll call it 0. We'll start at the 0th position. So we're saying I'm going to evaluate the whole list. Its size is 5. I need you to process the whole list of 5 and start with the 0th position. So given this structure, I need to work down and work up. So I just want to make sure you're with me so far. So what I can do is I can compare the current position, 0, with the last position, 10. I'm sorry, the last position, this is 4 here. So 1 and 10, I'm comparing those. And see, is 1 10 times 10 or 10 10 times 1? And if that's true, I add 1. Or just, I'm not counting them. I just say return true. I can just be done with it at that point. In this case, I shortcut it in a hurry, but let's pretend it's not. Let's make this one 10 and this one 5, just they don't have to be in order. Sorry, sloppy right there. All right, so I can say compare the current x with the current x, whatever that is, with the last item. Otherwise, if I didn't find one in this case, then let's keep the current x and reduce the size by 1. So in the first iteration, I look at this one against this one. And then if that's not, then I say, okay, well now the size is 4 and the current x is still 0. And so in the second iteration, I look at this one. And the third iteration, I look at this one. And the fourth iteration, I look at this one. And then if the size and the current position are the same, I stop looking. Does that make sense? But if the current position is not the same as the original size, then I want to make the current position. So this goes 5, 4, 3, 2, 1. I want to call it again, where the current position goes to 1 and the size goes back to 5. Again, the list stays the same, the 5 stays the same. So this goes all the way through, and the list stays the same all the way through. And so then now I go 0, 0, 0, 0, 0, 1, 1, 1, 1, 5, 4, 3, 2, 1. All right. And then I up the size again. So the size goes 2, 2, 2, and this goes back to 5, 4, 3. Okay, does that make sense, Demir?
Yeah, it makes more sense. Yeah.
So it's not easy. It's really super not easy. But given this pattern, which makes sense if I think about it, right? If I stop thinking about this and I look at this one and this one, this one, this one, and I start thinking in sense of positionality inside of the array, I do 0 versus length minus 1. I do 0 length minus 2, 0 length minus 3, 0 length minus 4, up until they match. And I do 1 length minus 1, minus 2, minus 3, minus 4. And I do 2 length minus 3, so far. So I do plus 1 here and minus 1 here. But so for this one, I do every minus 1 until they're the same. And then I do a plus 1. And then I end when the current position is equal to the original size. So my structure in the solution I have has an if statement, an else if statement, an else statement. And in the else statement, there's an if and an else. So it's 20 lines of code with a lot of curly brackets inside of it. So it's not a big bit of code, but it's the tricky part is getting all of, defining this up here and then figuring out how to do the logic to make this happen. And so I'm glad to work with anybody on this code directly, but the first thing I think is understanding the strategy. And that's what I wanted to do here. All right, anybody else have questions?
Yeah, I do. Still recursion problems, but the basic texting.
Okay,
Um,
so definitely we can jump into that. Any other questions on this one before?
I actually think that helped me. Thank you.
Yeah, and that's the thing about recursion. The reason why I have this diversity of problems, and definitely you can see why this is the hardest problem of this set. There's no rule that I could say to do recursion. If there's X loops, then there has to be Y parameters or something like that. It's about finding clever tricks to make this happen. There's probably other ways to solve this problem. This is not the only way to do this, I'm sure. This is the way that I came up with. And I didn't do a bunch of searching on other ways. There might be more efficient ways. Maybe I should. But if this meets my needs and it's fast enough, why would I spend extra hours of my employer's time that they're paying money for me just to make this a little bit faster? So I, as a academic, it's like, yes, I want to explore the fastest possible way and optimize it. As a pragmatic person who worked in industry, I need to find some way to make this work. Mind you, one way to make it work is iteratively. Done. It worked. But the point of this is to practice recursion. And there is some elegance in this recursion to some degree. All right, so I'm going to stop
Oh,
this.
thank you.
Yeah, absolutely. I'm going to stop this recording again, and it'll be out there for anybody to review. Um, so as good as this camera and my handwriting are, but at least we get the idea of it. So another recording in the dust.